Hi everyone, this is Gomadi, Department of Electronics Engineering, VLSI Design and Technology. Now we are going to discuss about 8051 microcontroller timer. In 8051, there are two timers are available called the timer 0 and timer 1. They can be used either as timer or as event counter. Both timer 0 and timer 1 are 16 bits wide. Since 8051 has an 8-bit architecture, each 16-bit timer is accessed as two separate registers of lower byte and higher byte. Timer 0 register. So timer 0 register has 16 bits. The lower 8 bits are TL0 and higher 8 bits are TH0. The 16-bit registers of timer 0 is accessed as lower byte and higher byte. The lower byte register is called TL0 and higher byte register is referred as TH0. These registers can be accessed like any other registers. Such as A, B registers and etc. For example, the instruction move TL0 25H, it means that load the value 25 into TL0. Timer in the timer 1 has also 16 bits. Each 16-bit register is split into two bytes referred to as TL1 and TH1. Lower byte and higher byte. These registers are accessible in the same way as registers of timer 0. Next is T-mod register. T-mod register is 8-bit register used to set the timer mode of timer 0 and timer 1. So bit 7 and 3 consist of gate. If bit 3 and 7 are in 1, then it is enable timer counter only when int 0 or int 1 pin is high and tr0 tr1 is set. If bit 7 and 3 are 0, then enable timer counter when tr0 or tr1 is set. Bit 6 and 2 counter timer. If it is 1, then it is used as a counter. If 0, it is used as a timer. Next is bit 5 and 4, 1 and 0. It is a mode M1 M0 timer counter mode select pin. If 0 0, then it is a mode 0. It is a 13-bit timer mode. If 0 1, then mode 1 operation. It is a 16-bit timer mode. If it is 1 0, then mode 2. It is 8-bit timer counter auto reload mode. 1 1, it is mode 3. It is a split timer mode. Next is TCON register. TCON register is 8-bit control register and contains of timer and interrupt flag. Bit 7 is TF1, timer 1 overflow flag. If 1, timer overflow occurred. If it is 0, then timer overflow not occurred. Next is bit 6, TR1, timer run control bit. If 1, timer 1 starts. If 0, timer 1 stops. Bit 5, TF0, timer 0 overflow flag. If 1, timer 0 overflow occurred. If 0, overflow not occurred. Next is bit 4, TR0, timer 0 run control bit. If 1, timer 0 starts. If 0, timer 0 stops. Bit 3, IEI, external interrupt edge flag. If 1, external interrupt occurred. 0, external interrupt processed. Next is bit 2, IT1, external interrupt 1 trigger type select bit. If 1, interrupt occur on falling edge at int 1 pin. If 0, interrupt occur on a low level at int 1 pin. Next is bit 1, IE0, external interrupt 0 edge flag. 1, external interrupt 0 occurred. 0, external interrupt 0 processed. Bit 0, IT0, external interrupt 0 trigger type select bit. If it is 1, interrupt occurs on falling edge at int 0 pin. If it is 0, interrupt occur on a low level at int 0 pin. Next topic is serial communication protocol. So communication is a very well known terminology that involves the exchange of information between two or more mediums. In embedded systems, communication means the exchange of data between two microcontroller in the form of bits. This exchange of data bit in a microcontroller is done by set of defined rules known as communication protocol. If the data is sent in series, that is one after the other, then the communication protocol is known as serial communication protocol. More specifically, the data bits are transmitted one at a time in a sequential manner over the data bus or communication channel in serial communication. Types of communication protocol. There are different types of data transfer available in digital electronics such as serial communication and parallel communication. Similarly, protocols are divided into two types such as serial communication protocol and parallel communication protocol. Examples of parallel communication protocol are ISA, ATA, SCSI, PCI and etc. Similarly, example of serial communication protocols are CAN, Ethernet, I2C, SPI, RS-232, USB and etc. So these are the two diagram shows the serial communication and parallel communication. Transmission modes in serial communication. In serial communication, data is sent in the form of bits. And it is well known that binary 1 represents the logic high and 0 represents logic low. There are several types of serial communication depending on the type of transmission mode and data transfer. The transmission modes are classified as simplex, half duplex and full duplex. Simplex method in the simplex method, either of the medium that is sender or receiver can be active at a time. So if the sender is transmitting data, then receiver can only accept and vice versa. So simplex method is a one-way communication technique. The well-known example of a simplex method are television and radio. Second one is half duplex. So in half duplex method, both sender and receiver can be active but not at the same time. So if the sender is transmitting, then receiver can accept but cannot send and vice versa. The well-known example of half duplex is the internet, where the user sends a request for data and gets it from the server. Third one is full duplex. In full duplex method, both receiver and transmitter can send data to each other at the same time. The well-known example is a mobile phone. Apart from this, for appropriate data transmission, the clock plays an important role and it is one of the primary source. Malfunction of the clock results in unexpected data transmission, even sometimes data loss. So the clock synchronization becomes very important when using serial communication. So the clock synchronization. The clock is different for serial devices and it is classified into two types: synchronous serial interface, asynchronous serial interface. First, let us see synchronous serial interface. It is a point-to-point connection from the master to slave. This type of interface, all the devices use a single CPU bus to share data and a clock. The data transmission becomes faster with the same bus to share the clock and data. Also, there is no mismatch in baud rate in this interface. On the transmitter side, there is a shift of the data onto a serial line providing the clock as a separate signal, as there are no start, stop and parity bits added on the data. On the receiver side, the data is being extracted using clock provided by the transmitter and converted to serial data back to parallel form. So the well-known example of synchronous serial interface is I2C and SPI. So this is the simplest block diagram of the synchronous serial interface. Next is asynchronous serial interface. So this diagram shows the asynchronous serial interface. In asynchronous serial interface, the external clock signal is absent. The asynchronous serial interfaces can be seen mostly in long distance applications and are perfect fit for stable communication. The absence of an external clock source makes it rely on several parameters such as data flow control, error control, baud rate control, transmission control and reception control. On the transmitter side, there is a shifting of parallel data onto the serial line using its clock. Also, it adds the start-stop parity check bits. On the receiver side, the receiver extracts the data using its clock, converts the serial data back to parallel form after striping of the start, stop and parity. Thank you.